Welcome to our lecture on cytokines and chemokines. Over the next few minutes, we are going to explore exactly how immune cells communicate with one another to coordinate complex defenses against pathogens.
Think of these proteins as the text messages and GPS coordinates of the immune system. Cytokines are primarily used by immune cells to talk to each other, while chemokines act as a chemical trail to guide cells to where they are needed. And importantly, even non-immune cells can send out these signals to call for backup.
Learning about these molecules can feel a bit like reading alphabet soup. Cytokines are grouped by structural similarity and usually have a prefix or suffix indicating their family. For example, interleukins were named because they facilitate communication between leukocytes, or white blood cells, though we now know other cells use them too.
Seriously, when a virus invades, the immune system mounts a type 1, or Th1, response. This is orchestrated by type 1 helper T cells and is geared towards cellular immunity. The cytokines released here, like IL-2 and interferon gamma, are specifically designed to activate killer cells and macrophages to hunt down and destroy virally infected cells.
Now, if the threat is a parasite rather than a virus, the body uses a Th2 response. This shifts the focus to humoral immunity, meaning antibody production by B cells, and activates cells like eosinophils and mast cells. Interestingly, while this response is great for fighting parasites and healing wounds, it is also the main culprit behind allergies and asthma. For fungi and extracellular bacteria, we rely on the Th17 response. Driven by the cytokine IL-17, this profile is incredibly effective at recruiting a massive swarm of neutrophils to the infection site. It also uses IL-22 to help barrier cells in the gut and lungs heal. However, if this response becomes overly active, it can lead to inflammatory conditions like irritable bowel syndrome. After the battle is won, the immune system needs to hit the brakes to prevent collateral tissue damage or autoimmune disorders. This is the job of regulatory T cells. They release anti-inflammatory cytokines like IL-10 and TGF-beta, which actively suppress other immune cells and promote tissue repair. Switching gears to chemokines, these are the molecules responsible for chemotaxis, literally guiding immune cells to specific locations. They are divided into families based on the arrangement of cysteine amino acids in their structure. A quick tip: if you see an L in the name, it's the signaling ligand, and if you see an R, it's the receptor sitting on the cell surface.
Let's look at the CC chemokine family. These generally specialize in moving lymphocytes and monocytes around the body. For instance, CCL2 helps drive that Th2 allergy and parasite response we talked about earlier, while CCL3 leans more towards supporting a Th1 antiviral response by bringing in macrophages.
The CXC family has a slightly different primary job. They are the masters of neutrophil migration and tissue repair. CXCL8 is famous for calling neutrophils to the front lines of an infection. Meanwhile, chemokines like CXCL7 help stimulate angiogenesis, which is the growth of new blood vessels necessary for healing damaged tissue. Lymph nodes are incredibly organized structures, and that organization is entirely driven by chemokines. Stromal cells release CCL21 to bring in dendritic cells, which in turn release CCL18 and 19 to pull in T and B cells from the bloodstream. It is a highly coordinated chemical relay race that ensures the right cells meet at the right time. To wrap things up, while the sheer number of cytokines and chemokines can seem overwhelming, they are essential for survival. By mixing and matching these signals, your immune system can mount a highly nuanced, perfectly tailored response to whatever specific threat you might face.